Hi guys, welcome back to my channel Pirai Academy. In this video, we are going to see about a Leetcode question number 845, longest mountain in an array. You may recall that an array is a mountain array if and only if. So there are some set of conditions, okay? Array.length should be greater than or equal to 3, okay? There exists some index I, okay? 0th index with 0 less than I less than array dot length minus 1. So index should be in the range of 0 and up to the array length minus 1, okay, such that array of 0 should be less than array of 1 and it should be less than according to some particular point of index, okay. And then again from that particular index to the next final index there should be a greater than symbol. Like for example, see this array, see this particular array 1 4 7. So these are incrementing and then 3 2 or decrementing. So it is like a curve which increases then decreases. So it forms a mountain, right? If you plot this in your graph, it will be like mountain. For example, if this is a graph, okay. Now let us take these things, okay, or let us take entire thing. Next we can find out. So here comes 2, here comes 1, then here comes 4, here comes 7, and then here comes 3, here comes again 2, then here comes 5, okay. Then if I plot it, it will be like something like this, right? Now from this diagram you can say this forms a mountain, this forms a mountain, right? That's what they are asking us to find, okay. So what they are asking us to find, they are asking us to return the longest subarray, the longest length mountain, okay. There may be of 2 or more mountains also, right? So at that particular time we want to focus on which is the longest mountain and we want to return their length alone. We don't want to return the entire mountain, we only want to return the length alone. Can you understand this? So this is what they are asking us to find out in this problem statement. For example, see here 2 1 4 7 3 2 5. So here I already mentioned here, I drawn a graph, right? So in this graph you can see 1 4 7 3 2, it forms a mountain. It is incrementing curve then decrementing, this forms a mountain, okay. So here there is only one mountain is formed, okay. So I can also tell you 4 7 3, this is also a kind of mountain. 4 7 3 is also a kind of mountain, but it is smaller, it contains of 3, but here it contains of 5 for my red color square. And also I can tell you 4 7 3 2 is also one of kind of mountain. But among them all, the only best mountain I can tell you is 1 4 7 3 2. Can you understand this? Of length what? 5. So 5 is going to be my output. Now hope you understand the entire problem statement, right? Now how we are going to do this? So the simple brute force approach. Let us start from brute force approach. Always remember this, okay. Whenever you are solving a new kind of question, mainly in technical HR, you want to start from brute force approach and optimize it by yourself, okay. That's going to be the best approach and best kind of the answer you can give to the interviewer, okay. Fine. So brute force approach is going to be generate all possible subarrays, and just check for the conditions, okay. If the condition is true, then take the maximum among all. So this is going to be your easiest brute force approach. Can you understand this? Okay, so what I mean is just generate all possible subarray. For that I'll be giving the link in the description how to generate all possible subarray, okay. Just go and watch it. So that's going to be primary, that's the easiest thing, okay. And just apply these certain rules they have given in the question, problem solved. Yes. So this is what your brute force approach. But unfortunately what's going to be my time complexity? It goes up to O of n cube, and space complexity will be O of 1, or maybe the space complexity will be O of n, okay, because I will be taking an auxiliary array to store the subarrays. Okay, so the time complexity and space complexity analysis will be like this for the brute force approach. but we can also optimize it. So let us optimize it. So basically, whenever we are going for the optimization, we don't want to store it. We don't want to just go again and again to the same thing. So that's going to be the optimization. Okay. So how I am going to optimize it? So let me tell you how I am going to optimize it. Just follow this. Okay. Follow this step. It is going to be simplest thing. Okay. So see here. One of the type is generating all possible combinations. Another type is if I have a mountain like this. If I have a mountain like this, then I will be starting from this 7. I will be starting from this 7 and go on and checking whether its left side is how much time it is reducing. Okay, and go on to its right side and check how much time it is reducing. So that's going to be the slope. That's going to be the mountain. Can you understand this? What I mean is, see here. Let me take a graph. Okay. 1, 2, 3, 4, 5, 6, 7. So always whenever these kinds of problems are arising, just put a graph first, then go for a logic next. Such a way that you can easily convert that graph into a logic. Okay, so this is going to be your graph, and similarly, what's going to be my logic is, see here, mountain should have both left and right. Mountain should have both left and right. So I can tell you, I cannot have a mountain whose center is this 2 or whose center is this 5. Can you understand this? For this 2, there is nothing in its left. For this 5, there is nothing in my right. So where should I start? Where should I start? I should be starting from index number 1. So I should be starting from index number 1. So here I will be starting from this 1. Okay, let me first just plot the points. So here is 2 and here is 1. Okay, now I am starting from 1. And now check whether this one left side is lesser than this one. No, it is not lesser than. Okay, meanwhile, whether its right side is lesser than this one. No, which means 1 cannot be the center point. 1 cannot be the center point. Can I understand this? Yes. Okay, now go to the next thing. So this 4, whether 4's left side is small, left side is lesser. Yes, 1 is lesser than 4. So which means here comes the 4, right? So 1 is lesser than the 4. But 7 is greater than the 4. 7 is greater than the 4. So I cannot take this as my center. Yes. Then go to the next thing. 7. 7 means something like here. Okay. Now whether 7 left side, the previous element, is lesser than the 7. Yes. Whether its right side is lesser than the 7. Yes. Yes. So here I am going to apply my logic. Because 7 is going to be my center. 7 is going to be my center where it is the peak. It is the peak value of the mountain. Can I understand this? What my approach is, I am going to the peak. And I am going to find what is my floor here, what is my floor here. Add it, boom, that's it, answer. Can I understand this? Okay. So 7. Now first of all, go towards the left side and find out what is going to be the floor. What is going to be the very deepest part, and go to the right side and find the deepest part, and that's going to be my mountain length. Can I understand this? Okay, so let us go to the left side. If I go to the left side, it will be like, first I will be taking this 4. Okay, so because 7 is greater than this 4, so it is a valid thing, right? So initially I will be taking my length. Let us take length. Okay, initially I will be taking length as 1. When I visited this 4, I will be checking whether this 4 is less than its next value, which means 7. Yes, it is. So just add 1. Okay. Now go to the next left thing. So the next left thing is this 1. Whether this 1 is lesser than this 4. Yes. So add 1 to it. Okay, go to the left thing. Okay, 2. Whether this 2 is less than this 1. No. Which means I should be stopping it. Stopping it. What it means is, I gone like this, up to this. Okay, whether I want to go here or not. No, because it is not a down slope, it is a up slope. So I cannot go. Okay, so stop here. Now it's time to go towards the right side. Okay, go towards the right side. Now here comes the 3. 3 is lesser than 7. Yes. So add 1 to it. Okay, now go to the next thing. 2 is less than the 3. Yes. So add 1 to it. Okay, go here. Whether 5 is lesser than this 2. No. At this particular point, I should be stopping here. I should be stopping at this particular index. So here 0, 1, 2, 3, 4, 5 and 6. So stop at this particular index 6. Okay. And now what should I do? I'll be making this as my I want to check this with my result. Initially the result will be 0 at initial. Okay. Now whether 0 or 5, which is greater? 5 is greater. Obviously 5 is greater, right? So I'll be making this as 5. So result is now 5. Hats off now. I want to do this process throughout all the elements. Okay. Now I want you to understand. See here and all we are just adding 1 to it. Now just understand this. This is going to be the crucial part. Just understand this. Now this 7, from this 7 only I checked the mountain length. So I gone up to this point and up to this point. Okay. Now checking again for this 3 is useless. Checking again for this 2 is useless. So let me directly jump to index number 6. Can you understand this? So I will be directly jumping to the index number 6. Now for this index number 6, this 5, whether its previous element is lesser than 5, yes, obviously. Whether it has any right element, no, because it is a last element, right? So I don't have right element, so just skip. So now I will be at the index number 7. So index number 7 is not there, so stop here. Can you understand this? So what is my result? It is 5. So here there is only one possible mountain, but in your real time there may be of 2 or more possible mountains also, right? So there also this logic will be fine. Okay. Now tell me, what is the time complexity? So it will be O of n, and space complexity will be O of 1, constant space. So why the time complexity is O of n? Many will be confused here as time complexity is O of n square. No, here we will be at most going through 2 times for the same element, which means 2n, where 2 is a constant, so it will be n. Can you understand this? So this is going to be a time and space complexity analysis for this particular problem. Now let us see the code. So just a minute. So see here, this is going to the code, and I have written this in a Java. If you want C++ or Python, just go and search in the description. Okay. Now see here, initially I will be starting from the index number 1, and my maximum, the result will be 0 initially. Okay. Now count is equal to 0. This count is going to be counting the mountain length currently. It is not the maximum mountain length. It is mountain length currently. Okay. What I kept there is like length. I kept in drawing as length, right? So this length is of what? M there. Sorry, count there. Okay. And this M represent as the result I drawn in the drawing explanation. Can you understand this? Okay. Fine. Now, while my index is less than the last index, so you can either put the last index or you can also put as the array dot length of. That's totally fine. However, at this particular condition, it will be failing. Okay. That's your wish. You can either keep like that or you can either keep like that. That's your wish. Okay. Now, at first, what should I check? I'll be checking whether it is a peak element. How I am going to check the peak element? If the previous value and the next value of the current value is lesser than, then it is going to the peak value. Yes. Now count is equal to 1 initially, because the peak value will be counted as 1. Okay. Now j is equal to I, which means I just starting from that peak value. Now I want to go towards the left side. And check whether the previous value is lesser than the current value. If it is so, just increment the count and do j minus. Okay. Now again start from the peak value. J is equal to I. Okay. And again go towards the right side. Okay. And check whether the next value is lesser than the current value. If it is so, just do count plus and do j plus. Okay. Now next the result will be updated as the maximum among the count and the result itself. Okay. Now j will be incremented as, I will be incremented to j. Because this particular condition is satisfied, right? So it is like there we don't want to go again for all the elements in the right side. Okay, we just go to the ending point itself. So that's the reason why I am just put the I is equal to j. Okay, else what should I do? I plus. Else I should be doing I plus. Now return the result. That's it. So this is going to be an entire code for this particular problem, and in the question also they are asking us to find using one pass. Here we are using only one pass, and also we can solve it in constant space. Okay, so this is going to be your entire solution, and if you really understood this solution and you like this video, just like this video and subscribe to my channel, and don't skip any videos in my channel, because all will be helpful once you are going for a interview. And if you have any doubts regarding this, just comment below. Okay, thank you.